my goblins and ghouls, my name is Steven, and today we're building a pick and place. Again. Yeah, I know, I already made one. I used the Openbuilds Acro 55, and it worked super well for figuring out a lot of stuff, but it's not gonna work for the long term. It gave me a great foundation to learn, but I need to make my own now. So today we're making our own. So what am I gonna change? First off, the height of the front and back rails are just a little too high for the feeder to actually work. The nozzle can't actually reach over and pick components out of the feeders with this setup, so I can't really use the feeders on this thing. The second problem is that the motors for the Y-axis come down really low on the machine, and eventually I want to put a conveyor belt in here so I can just automatically feed boards through. And with the motors as far down as they are, I can't really do that. I could put extra long, tall feet on it, but it's not designed for that. I kind of want to just design the whole thing from scratch with all the things I want it to do in mind. Plus, if I print a lot of the parts that are going to go together, which I'm planning on doing, then I can put all the little things that need to go into it integrated into each 3D printed part. It's going to be really cool. Super integrated, very specific for what it's going to do. Awesome. Well, there you have it, folks. Today we're going to put this sucker to rest and build a brand new machine. Now that I actually know what I want. All right, let's get this thing off here. Yep, nope, that design kind of sucked. I got like a third of the way through assembling it and I realized it was just bad. You saw in one of the parts I was drilling holes in it because I just like flat out forgot to add the embossed little area for the screw head to go in. So I went back to the drawing board and hopped back in Fusion and just redid the whole thing. Even as I was putting it together, I was like, this is just not even worth my time to assemble. I have all these things that I know are wrong with it. Let me just go back and do it again. And I did. And I have been running prints solid for the past like 72 hours, reprinting all these parts. It's tricky figuring out when to like pull the plug on something. Like, is it actually gonna be beneficial to finish assembling this thing and learn as much as I can from this iteration before going through and making another one? Or should I just cut bait and make a whole brand new one? So I scrapped it. Also, because of the coronavirus coming through the United States, I'm working from home, so I can't use the laser cutter anywhere. I don't have one at my place. So I had to redesign a lot of the parts to be printed instead of be laser cut, because I am in my apartment for this foreseeable future. Plus, I like the idea of using printed parts more because they're easier to recycle than acrylic as far as I'm aware. I have a Filostruder, so if I wanted to, I could take old revisions and melt them down and make new filament out of them, so I'd prefer to go printed if possible. Plus, a lot more people have printers than they do laser cutters, so it also makes the parts more accessible to more people. Alrighty, this is such a funky looking part, huh? I love this part. Alright, let's take another crack at this and try and make this machine one more time. Alright, here's the meat of the thing. It's a big ol' aluminum cage, and it is ridiculously sturdy for it being just like a handful of 3D printed parts. It's super rigid, it's not going anywhere. But before I add on all the axes, I wanted to show you. This back bar here is adjustable, and what that lets you do is either have a bigger area to be able to pick and place bigger boards, or slide it down like this, and then now you have an extra rail that new feeders can go on that the nozzle can actually reach. So you have an option to either have just the one rail for feeders or to have two, depending on the size of your board and how many components it has and all that stuff. Next is bolting on the X and Y axes. then the head, then the nozzles. Woo! Axes are all mounted, the motors are on, all the control cables are all tacked in and tightened up. The last thing to do is get all the electronics from the Acro version of this whole thing and plop it into this guy and then get it moving around just like the other one was. Where is it all? Oh, there. All this stuff. I need the pump, the display, the actual like motor driver and like main Marlin control board. All that needs to plug into these motors and then it should be moving around no problem. And then I'm done. And then I'm done. Ooh! Let's get this thing wired up. Gosh darn works. It actually moves around, all the axes drive beautifully, and the best part, the nozzle can pick components off of the feeders. Yeah, it works great. It works awesome. I just put this little board in here to give me a place to just test where components are actually being placed by the whole thing. Ultimately, I'm gonna convert this piece into a little place where I can have the head exchange out for different nozzles and add the upward facing camera so the whole system can check and see where the component actually is on the nozzle so it can adjust and place it really precisely. And in terms of plastic, this is maybe like 15 bucks. The aluminum all said and done is probably 80. With motors and stuff, you're probably looking at like under 200 bucks for a BOM cost. Granted, I've spent like over $1,000 on this project with all the prototyping and different PCBs and stuff that I bought. I found that trying to integrate as many features as I possibly could into the prints worked out awesome. So for example, on the Openbuilds gantries, they have a flat sheet of acrylic and then they have a couple spacers to get the bearings offset enough that they'll actually like go into the groove on the aluminum extrusion. I don't want to have to deal with a separate part and a separate cost of a little spacer. So instead I just printed the spacer into the part and it works awesome. It works so well. That's one of the coolest things to me about being able to print parts is that one single object can have a whole bunch of different features and functionality kind of baked into it without any added cost. You can reduce your part count, which makes things a lot easier to assemble, and especially in this case, it reduces the cost of the whole thing too. Each one of those little aluminum spacers that I wanted to use was like $4 or something, and I would have needed 16 in this whole machine. That's like $64 worth of just aluminum spacers, but instead I'm using probably 15 cents worth of plastic. Not only do I not have to worry about assembling it and keeping that part in stock, but I also save a ton of money on actually integrating that feature, that spacing, into the part. You love to see it. Okay, last thing is integration. New revision of the feeders, fixing all the mistakes I made in the first pass. New revision of the piggyback board, fixing all the mistakes I made in the first pass. And then tidying it all up and getting OpenPNP to control all of it. That is the next episode. All right, that's it for this one. I now have a Patreon, so if you'd like to support me there's a link in the description where you can become a patron. Thank you so much for watching, and I'll see you next time.